Okay, Seema. So yesterday we have studied equations for resistance, no ma? What we have studied? Resistance is directly proportional to L. Resistance is inversely proportional to area of cross section. These two we have studied, no? So if you combine both of them, what I will write? R is proportional to L by A. And what is the proportionality constant? R is equals to rho L by A, where rho is called as resistivity of the conductor. Okay? Now what I am doing is, I will stretch a wire or I will compress a wire. Okay? So this is a wire. So, లావుగా దిబ్బరొట్టలా ఉంది చూడండి. So area of cross section is bigger, length is smaller. So if I stretch this one, then what happens ma? Length increases and area of cross section decreases. But whatever it may be, total volume always remains a constant. No? Are you able to understand ma? Length has increased, area of cross section has reduced, volume always remains a constant. So in this condition, how can I manipulate the equations that we are going to see now? See ma. So we know that R is proportional to L by A, no? Clear, no ma? So therefore, what I will do is, in the first condition, I will multiply this one by, okay ma. So, see ma, I will multiply this one by L by L. Will anything happen? L by L to multiply just the image changes, nothing will change. Because L by L, they get cancelled with each other. But this relation will become R proportional to L square divided by area of cross section into length is what? Volume. Clear, no ma? And volume is a constant, no? Volume is a constant because total volume always remains same, no ma? Even if I stretch this wire. Therefore, because volume is a constant, I can write R is proportional to L square. Okay? So therefore, same relation again, how I can write? I can write R1 by R2 is equals to L1 by L2 whole square. So what is the use of this relation, ma? Can you say, anybody? Why we have derived this relation? So ఒకటి వచ్చేసి మనకు ఏదన్నా పని ఉండాలి, లేకపోతే మనకేమన్నా పని లేకన్నా ఉండాలి. ఆ రెండిట్లో ఏది కరెక్ట్ చెప్పండి. See, this is to compare resistance of wire in two different conditions. L1 is before stretching, L2 is after stretching. So if I want to compare the lengths, I can compare the resistances also. And here by this equation, R is not directly proportional to L. R is directly proportional to L square. In which condition? If you stretch a wire, total volume when it remains constant. Understood, no? This is one case. So, second case, what I can do? Case number 1. Case number 2, these are the shortcut methods. By general methods also you can do, but lot of time will be wasted. So, R is proportional to L by A. Okay? This I will multiply by A by A now, this time. Previously I have multiplied by L by L, no? Now I am multiplying by A by A. Will anything change? Nothing will change. So this relation becomes R proportional to V divided by A square. And what is meant by V? V is again volume, which is again a constant. Clear, no? So therefore in this condition I can write R is proportional to 1 by A square. Okay? So therefore again this equation I can write R1 by R2 is equals to A2 by A1 whole square. I can write like this. Okay? So if I want to compare lengths after elongation, I can use this relation. If I want to compare areas, area of cross section after elongation, I can use this relation. Okay? That's it. Very beautiful relations. మీరు పరువు తీసేటట్టు ఉండారా? ఎవర్రా మీకు ఫిజిక్స్ చెప్పిందంటే చూడండి. So find resistance of, so let us consider this is R2 R2 we are supposed to find out. Length is how much? Length is 1000 meters. Okay ma? And what is the area of cross section? Area of cross section is 25 square millimeter. This is one condition. Clear, no? Second condition, R1 value already he gave. What is the resistance? Resistance is 1 by 58 ohms. Clear, no? And what is the length he gave? Length is 1 meter. That is the meaning of this one, no? అర్థమవుతుందా ఏం జరుగుతుందో ఇక్కడ? For 1 meter length, this is the resistance. And for how much area of cross section? 1 square millimeter of cross section. So therefore A1 value is how much? A1 value is 1 square mm. This is the data which is given. Okay. R2 we are supposed to calculate. R1 he already gave. So resistance is directly proportional to what? L by A, no? So therefore same relation I can write like this also, no? R1 by R2 is equals to L1 by L2 multiplied by A2 divided by A1. That's it. Huh? I want R2, no? So you take the reciprocal of this. So R2 by R1 is equals to L2 by L1 multiplied by A1 by A2. So therefore R2 is equals to how much? R1 multiplied by L2 by L1 multiplied by A1 by A2. So just substitute all the values, you will get the answer. Okay. So therefore R2 is equals to R1. Initial resistance is 1 by 58. Final length 1000. Initial length 1. So here also square mm, here also square mm, no? So you need not convert this one into square meter square. Square meters you need not convert. Okay. A1 is 1, A2 is 25. So just do this calculation, that is my required resistance. And the answer of this one is 20 by 29 ohms. 20 by 29 ohms. That is the answer which you should get. Is it clear? That's it. Sima. So copper wire of diameter 1 centimeter. So what is the initial diameter? It is 1 centimeter. It has a resistance of 0.15 ohm. So it is drawn under pressure. So what is the meaning of this one? Initially, if this is the wire, so it is now made like this. This concept already we have studied, no? If you stretch this wire, what happens to its length? Length increases and diameter reduces. This is what happens, no? So that diameter is reduced to 50%. It means D2 is how much? D2 is 0.5 centimeter. That's all, no? Then what is the new resistance that he is asking us to find out? So here question is in between resistance and area of cross section, no? In diameter only you will get area of cross section, no? Sorry, in area of cross section only you will get diameter. So therefore which relation I can use? Already we have written, no? R is proportional to 1 by A square. Do you remember? ఇప్పుడే కదా derive చేసింది ఇది. So when you are discussing about lengths, then what is the equation? R is proportional to L square. But I am discussing about what? I am discussing about a diameter, no? Diameter is present in area of cross section. Are you able to understand? So therefore substitute now. So therefore R1 by R2 is equals to A2 by A1 whole square. Clear, no? So therefore R1 by R2 is equals to, what is the formula of area of cross section, number? Pi d by 4 whole square. That's all, no? Divided by pi d1 by 4 whole square. Not whole square, pi r square, no? So this square also will be there and whole square also will be there. Pi d by 4 whole square, no? Pi d by 4 pi d by 2 na? Pi r square, no? Pi d2 by 2 d1 by 2. Are you able to understand? Area of cross section pi r square only, no? In terms of diameter I can write pi d by 2 whole square like this. Understood, no? So therefore again square is also present, no? So I am writing square also. Now do the calculation. So pi and pi, 2 and 2 get cancelled. So therefore R2 by R1 is equals to D1 square divided by D2 square whole square. Okay. So R2 is equals to R1 multiplied by D1 by D2 whole power 4. This is what I will get. Okay. So therefore, what is the initial resistance? 0.15 multiplied by initial diameter is how much? 1. Final diameter is how much? 0.5, that is 1 by 2 power 4. Clear, no? So therefore, it is 0.15 multiplied by 2 power 4 is 16. So 16 into 0.15 is how much? Calculate that, that is our answer. Okay, ma? So have you understood, ma, how we have done this one? Okay, see, ma. So in a discharge tube, what is meant by discharge tube, we know, no, ma? So there will be 2 electrodes and this will be a glass tube. Okay? And they are connected to positive and negative terminal of a battery. So this is called as a discharge tube. Are you able to understand? So in this tube, what is happening? Hydrogen ions. Hydrogen ions means what? Consider this is positive, this is negative. Now can you say hydrogen ions will move in which direction? Chapandi. Protons will move in this direction, no, ma? Because always they are repelled by positively charged terminal, they are attracted by negatively charged terminal. So protons will move in this direction. Okay? And electrons will move in which direction? Electrons will move in opposite direction. This is what happens, no? These are positively charged bodies, whereas electrons are negatively charged particles. So their movement will be always in opposite direction. Understood, no? So therefore, can you say what is the total amount of charge flowing per second? So charge flowing per second is how much? Can you say, anybody? Charge flowing per second is how much? First of all, we should calculate charge. So how many protons are traveling, ma? 1.2 into 10 power 18 protons. And in opposite direction, how many electrons are traveling? 2.8 into 10 power 18. What do you understand? Anybody? See, what is meant by charge actually? First of all, what is meant by current? Flow of positive charges, no? Now see. It means this is the flow of current, no? Flow of protons is nothing but flow of current. And electrons are moving in opposite direction. If electrons are moving in opposite direction, what is the meaning of it? If electrons are moving in one direction, it means again positive charges are moving in opposite direction. Ninnane kada chadukunindi manamu. Are you able to understand, ma? Protons are traveling in one direction. Electrons are traveling in opposite direction, means that because of flow of electrons also, positive charges are moving in the same direction as that of direction of protons. Negative charges ee vaipu vastunnai ante meaning emi? Positive charges ee vaipu veltunnai ane kada dani artham. Are you able to understand, ma? So therefore, total charge flowing is nothing but charge because of protons plus charge because of electrons. Both we have to add them, because it is equivalent as if both positive charges are moving in one direction. Arthamainda emanna? Are you able to understand, ma? So therefore, now see how many Q can be written as N into E also, no? So N into E of protons plus N into E of electrons. Okay? Now do the calculation here. So therefore, charge flowing per second. So how many protons are flowing, ma? 1.2 into 10 power 18. And what is the charge of each proton? Each proton charge is 1.6 into 10 power minus 19 coulombs. Plus, again, how many electrons are flowing? 2.8 into 10 power 18. And what is the charge of each electron? Again 1.6 into 10 power minus 19. Clear, no? So this is the total amount of charge which is flowing per second. Okay? So once I calculate charge per second, what is I? I is equals to Q by T only, no, ma? So nothing but this is nothing but current only, no? Charge per second is called what? Current. So this is the total amount of current which is flowing. Okay, ma? So therefore, if you do this calculation, how much it will be? So 1.6 into 10 power minus 19 if I take common. Similarly, 10 power 18 also if I take common, then it is 1.2 plus 2.8. 1.2 plus 2.8 is 4. So I is equals to 4 into 1.6 into 10 power minus 1 amperes of charge, current. This is the amount of current which is flowing in this discharge tube. Are you able to understand? So once I calculate the amount of current, supply voltage is already given, then what is the resistance? Resistance, how can I calculate? R is equals to V by I, no? So what is the potential supplied? 220. And what is the current? 4 into 1.6 into 10 power minus 1. Okay, ma? So therefore it is 220 into 0 divided by 1.6 into 4. So just do this calculation, you will get the total amount of resistance. That's all. And the answer which you should get is 334 ohms. 334 ohms. That is the resistance of this discharge tube. Okay. See, ma. So see this question. A wire having a mass of 0.45 kg. So what is the mass given? 0.45 kg. Possesses a resistance of 0.0014 ohms. This is resistivity. Resistivity is 1.78 into 10 power minus 8 ohm meter. Then calculate its length as well as radius. These two we are supposed to calculate. And density is also given as 8.93 into 10 power 3 kg per meter cube. Are you able to understand? So this is the data which is given. Okay, ma? Now what he is asking us to find out length, no? So let us see how we can calculate. R is equals to rho L by A. We have this formula, no, ma? R is equals to rho L by A. Why we are using this one? Because resistance is given, resistivity is also given, length we are supposed to find out, and area of cross section can be written as pi r square, no? So therefore rho L divided by pi r square. I will write like this. So let it be my first equation. And he gave density also, he gave mass also. So we know that density is equals to mass by volume. Okay. Now see, my if what is wire will be of this kind of shape, no? Wire will be of this kind of cylindrical shape, no, ma? So if length of the wire is L, area of cross section of the wire is A, then how can I calculate its volume? Volume of the wire is nothing but area of cross section into length. This is how I calculate, no? Area again I can write a pi r square, no? So pi r square multiplied by L. I can write like this. Area of cross section multiplied by length is called as volume. Okay. So therefore density is equal to mass by volume. So density is equals to mass divided by volume. Volume is how much? Pi r square into L. So therefore mass is how much? Mass is equals to density into pi r square into L. Okay, ma? Huh? Huh? Right. Equation I can write like this, no? M is equals to D into pi r square into L. So this is my first equation, this is my second equation. Now if you observe these two equations, see how many unknown quantities are there, ma? Resistance is already given, no? Resistivity is also given. L is not given, R is not given. So L and R are unknown quantities. Similarly here also mass is given, no? Density is given. So here also R and L, they are unknown quantities. So what I will do is, here I have pi r square in division, here I have pi r square in multiplication. So I will multiply both of them, then pi r square and pi r square will get cancelled, you know. Techniques of solving, that's it. So what I will do, 1 multiplied by 2. Okay, ma? If I do 1 multiplied by 2, then R into M is equal to rho L by pi R square multiplied by here D into pi R square into L. Okay, so pi R square will get cancelled. So therefore R into M is equals to rho L D L. So R into M is equals to rho D L square. So therefore L is equals to square root of Rm divided by rho into D. Okay, so just substitute all the values, you will get the length. That's it. Understood, no? So what is the resistance given? Resistance is nothing but 0.0014. What is the mass given? 0.45. What is the resistivity given? 1.78 into 10 power minus 8. And what is the density given? Multiplied by 8.93 into 10 power 3. Okay, ma? So do this total calculation, you will get length of this wire. And the length you should get is 1.99 meters. 1.99 meters. That is my answer. Understood, no? So once I calculate length, I can calculate radius also, no? Now here in this total equation only R is the unknown quantity. Similarly, either you can take this equation also. Here also only R is the unknown quantity. So either use this relation or this relation, you will get R value also. Is it clear? That's it. So which equation shall we use? We can take any one equation, either first equation or second equation. Okay, ma? I will take first equation. So R is equals to rho L by pi R square. Okay, so therefore R square is equals to rho L by pi into R. So R is equals to square root of rho L by pi into R. So substitute all the values, you will get the radius of the wire. And radius 2.84 into 10 power minus 3 meter, or you can say it is 2.84 millimeter. That is our answer. Okay, have you understood, ma?